Selecting items from a hierarchical menu is a common interface task. Marking menus arrange menu items radially. To select an item, we draw a stroke towards it. Deeper menu items require more strokes. Eventually, we learn the strokes and draw them as experts, without waiting for menu visualization. But with more than 8 items, such menus are very difficult to use. Both selection speed and accuracy decrease significantly, especially in expert mode. The orientation of the stroke determines which item is selected. Yet strokes possess other geometric attributes including length and position, relative to the origin of some coordinate system. We introduced 2 variants of marking menus that consider both the orientation and the relative position of strokes. Our first variant is the Zone menu. We initially tap the screen to set the menu origin. The input area is split into zones about this origin. To select an item, we draw a stroke in the corresponding zone at the corresponding orientation. We can easily select from 32 different items and achieve expert performance. Our second variant is the Polygon menu. Again, we tap to set the menu origin, and this time the menu visualization appears as a polygon centered on the origin. To select an item, we draw a stroke over the corresponding edge of this polygon. We can easily select up to 16 items from this octagonal menu even in expert mode. We can simulate a device with a small input area, like the screen of a small PDA, by placing a cardboard cutout on our tablet PC. Our hand now remains roughly centered over the input area. The menu origin is fixed to the center of the input area, and the initial tab is eliminated. We conducted an experiment to compare the expert level performance of Zone and Polygon menus with purely orientation-based marking menus. The stimulus shows the set of strokes subjects must draw in the current trial. A blue stroke always indicates the first stroke, while red indicates the second. This stimulus is for a 2-level polygon menu of breadth 12. The stimulus disappears as soon as the pen touches the tablet. When subjects have finished drawing the strokes, the stimulus reappears and the system explains whether the trial was successful. Tapping the next trial button repeats the process. We had 18 subjects perform the menu selection task in 13 different conditions. Our analysis shows that both Zone and Polygon menus outperform purely orientation-based menus in terms of speed and accuracy when breadth exceeds 8 items. We have also developed 2 hybrid designs that combine purely orientation-based menus with Zone or Polygon menus. In these hybrids, if the initial stroke is very short, we treat it as a tab specifying the origin for the Zone or Polygon menu. Otherwise, a longer initial stroke gives us quick access to 8 items in an orientation-based menu. Zone menus, Polygon menus, and our hybrid designs offer interface designers a wider set of options when choosing how to balance menu breadth and depth against speed and accuracy. We believe that these are promising techniques for building more effective pen-based applications and interfaces.